All right, this is our last module in interpolation of the steam tables, and in this module we're going to look at double interpolation in the superheated steam tables. So if we have a question like find the specific enthalpy of superheated steam at a temperature of 325 C and a pressure of 570 kilopascals, we can look in our steam tables and find out that our pressure 570 is not a tabulated value, and neither is our temperature 325 degrees C. And so we're going to have to do a double interpolation. Now we have our choice. We can do the vertical interpolation first and find the two values at the given pressure and then interpolate horizontally for that, or we can do it the other way around. I'm going to demonstrate this first way first. You may find it easier to do the two horizontals followed by the vertical. Whichever way makes most sense to you is the way that you can do it. Now I'm going to use the ratio equation method just because it saves me having to draw out the lines and calculate the slopes. It works out the same in every case anyway. And so, as I did before, I'll draw my 6 boxes. And I will start to fill in my values. Let's do the pressures first. This one's 600. This one's 500, and I'm looking for a value at 570. This is 3103.9. This is 3106.1. And this one is H320. And I always use a little denominator there to show that which one it is. So when I come back to do my second interpolation, I don't wind up using the wrong one in the wrong place. And so I'm going to set up my ratio equations as I did before. First one's going to be 570 minus 500 over 600 minus 500 is equal to H320 minus 3106.1 over 3103.9 minus 3106.1. And if I do that calculation, I get 70 over 100 equals H320 minus 3106.1 over, in this case, minus 2.2. 0.7 times minus 2.2 equals H320 minus 3106.1. And minus 1.5 plus 3106.1 equals H320, and that's 3104.6. So that's H320. And now I have to do the 340. So I'm going to put the boxes down, and I only need 3 boxes this time. As I mentioned in the other tutorial, if I have already done the 600, 570, and 500 ratio, I don't need to do that again. And so I have 3145.4, and I'll have this H340, and 3147.4. I'm going to build the ratios. And so in this case, I'm going to have 0.7 equals H340 minus 3147.4 over 3145.9. Whoops, 31.4, bad writing, minus 3147.4. And if I do that, I get 0.7 equals H340 minus 3147.4 over minus 2. And we'll keep on going. 0.7 times minus 2 equals H340 minus 3147.4 minus 1.4 plus 3147.4 equals H340, and 3146 equals H340. So now I have two values of enthalpy at 320 and 340 for a pressure of 570 kilopascals. So I've looked after that part. Now I have to do the interpolation in between for the temperature. And so I'm going to draw the boxes once again. And this time things are going to change a little bit. I have a 340, I have a 320, and I have a 325. And now my values in the other boxes are going to come from the values that I have just calculated in the first part of the interpolation. And so that's why I use these little numbers here to make sure I get the right one in the right place. So it's 3104.6, it's 3146.0, and this is going to be, let's just call this H at 325. And so now I'm going to build my ratio equations once again. If I build my ratio equations here, and here, here, and here. And so this looks like 325 minus 320 over 340 minus 320 equals H325 minus 3104.6 over 3146 minus 3104.6. And so I'm going to get a 5 over 20 equals H325 minus 3104.6 all over 41.4. And you notice that by following the method here, I don't get a negative number here, and that's all right. The math is going to save me. I'm going to do 5 times 41.4 over 20 plus 3104.6 equals H325. I skipped a couple steps there, but hopefully you've seen them often enough now. And that gives me 10.35 plus 3104.6 equals 3114.95 equals H325. All right, so I have 3114.95. Let's go back up and see if this makes sense. 3114.95, and if I look at this, it should be in here somewhere. It should be larger than both of those numbers, smaller than both of those numbers, somewhere in the middle here, and it's looking very good, so I like that answer. So there's double interpolation of the superheated steam tables to get an intermediate value between temperatures and between pressures.